In our next section, we're going to begin our discussion of the different types of multicast VPN deployments, or what's also known as the multicast profiles, which are going to be used to hop multicast traffic over the MPLS Layer 3 VPN. So in the case that we're talking about just normal global multicast routing, we don't need to worry about multicast VPN. Or in the case that we're talking about an MPLS Layer 2 service, like a VPLS. If you have a VPLS, you're tunneling over the provider, you're doing Layer 2 overlay, you're not routing regular unicast with the provider, which means that you don't need to run multicast routing with them. So in the case of a VPLS, if you turn PIM on, you would become PIM adjacent with your other routers or your other switches that are on the other end of the VPLS network. Okay, so what the mVPN deployment models are really going to affect is how is the service provider dealing with the customer traffic. So when it comes in, what's going to be the encapsulation format? We'll see that's going to be mainly two things. It could be going over a GRE tunnel, or it could be going, over MPLS labels. So from the customer's point of view, nothing is going to change. So the example that we saw up to this point, where the customer network is pre-configured with PIM in sparse mode, and we're using a rendezvous point. So we had router 5, if we go back to our diagram. Router 5 in the bottom left is our rendezvous point. This is going to be kind of the determining factor of whether our configurations are functional from the control plane point of view. Do we learn the BSR messages that router 5 is advertising to the rest of the sites? This is going to show us whether our iOS XRV is going to behave in the control plane or in the data plane. So some of the examples that we end up doing here may not be fully functional through iOS XRV, but hopefully we should be able to see the examples from regular iOS at least. Okay, so we also talked about what the provider network is doing in terms of their routing. Actually, we didn't actually mention this yet, which is going to be that the providers are participating in PIM with the customer edges. Okay, it should be a capital E, with the CEs. So just like in regular unicast MPLS Layer 3 VPNs, the provider and the customer, so the PE and the CE, they're running some sort of unicast routing protocol, like OSPF in our case. They do also need to run PIM. Now this is regardless of what is the mVPN deployment model. So the customer CE is always running PIM. It's not going to be using BGP to advertise the SG pairs. So you do have to be kind of careful of what the terminology Cisco is using for these different profiles, because in some of the documentation it looks like the customer edge should be running BGP for multicast. That's not the case. They're always going to be running PIM from the PE to the CE. It's the PE that's going to take those messages in and do something with them. Okay, so convert it into a PIM message, convert it into some sort of MLDP message for multi-point LDP, convert it into a BGP message. As long as the customer has their PIM reachability working, that's going to be everything that we need to focus on from customer side. Okay, so the customer multicast traffic is going to be hopped over the core, similar to using unicast routing. So regardless of what solution that we use, when we look at the state of the core, okay, the core in our particular case would be like XR2 or router 2. They're not going to have any state information that talks about the customer's MPLS. Or excuse me, not the customer's MPLS, the customer's multicast. Okay, so either way, this is going to be basically PE to PE that we're doing this config. Okay, so how does this work from a high-level overview? First thing we need to do is we're going to signal some sort of tree through the core of the provider network. Okay, so we could signal this with PIM, or we could signal this with MPLS. Within MPLS, there's a number of different sub-options. These are going to be the profiles that you choose. So it could be a traffic engineering tunnel. It could be multi-point LDP, which is going to be not necessarily new protocol, but this is the new introduction for it here in this section, because in unicast routing, you don't need to run MLDP. MLDP is just going to be for multicast. But this is going to be our first portion, that the network underneath the customer is going to have to be running some sort of signaling. Okay, so in our first example here, we're going to be running PIM on all of these interfaces in the underlay. Okay, so PIM is going to be running between all of these different routers. Okay, we're also going to have PIM that's running towards the customer. Okay, this is from the provider edge point of view. The key though, just like in an MPLS layer 3 VPN for unicast, is that this is going to be a different context. So we have VRF, B as in Brian, that's assigned to this interface. So this means that router 1 is going to say IP multicast routing, but it's going to be doing it specifically for VRF, B as in Brian. It's also going to have a separate IP multicast routing statement that is for the global table. So global table is going to go this way, VRF table is going to go that way. Okay, so we'll look at multiple examples here where we're signaling with PIM and we're signaling with MPLS. Okay, now the PE routers signal the tree over the core. Okay, so this is going to be our basically multi-hop that's going to go from, let's say, router 1 over to router 3. So we're tunneling the traffic now over router 2, so it's not going to have to look at the details of the multicast groups for the customer. Okay, the overlay protocol here could be PIM or BGP. Okay, PIM or BGP, depending on what the profile number is. The functionality is going to be the same regardless of what protocol that we're using. It just depends on, do you want to be troubleshooting PIM in your network or do you want to be troubleshooting BGP? It's not necessarily to say that one is better than the other. They both have the same functional result. Probably stick with whatever one that you are more familiar with. We'll see in the case of BGP, this is a new paradigm for BGP routing that we're basically taking things like the PIM register and the PIM join messages and we're encoding them as new BGP updates. So this would be just a new BGP AFI format that you would need to learn to verify and to troubleshoot the network. Okay, last but not least, we have to encapsulate the traffic. So encapsulation is going to go either over a GRE tunnel or it's going to go inside of MPLS. Okay, so the deployment models are going to be combinations of these. So what is the protocol that we're running? Is it IP version 4 in the global table or is it VPN version 4? Okay, in our examples, we're going to be looking at just VPN version 4. So this is traffic inside an MPLS layer 3 VPN. Then we need to look at how are we signaling the customer's traffic, or the customer's multicast traffic, could be PIM or could be BGP. How are we signaling the core itself? Okay, so it could be PIM, could be multi-point LDP, could be traffic engineering. And then finally, how do we encapsulate the packets over the core? Okay, so how do we know what profile does what? This is where our leaning on the documentation is going to help here. Okay, so we have two documents that we're looking at, which are the mVPN profiles in iOS, and then also the mVPN profiles inside of iOS XR. Okay, so let's start with iOS. This is under IP multicast and then config examples and tech notes in the documentation. And you can see there's a ton of profiles. So there's 27 profiles from 0 to 26 inclusive. Not all of these are actually supported in the code. We're not going to be going through 27 examples here, 27 different designs. We're mainly going to look at what are some of the variations. Then once you have a firm grasp on, what do those do in terms of the underlay, or excuse me, in terms of the encapsulation, in terms of the underlay signaling, the overlay signaling, then hopefully you should be able to combine the other ones just based on following the config examples in this section. So definitely this is something that you cannot memorize, or I guess you can, but I choose not to in this case because there's just so many variations, right? Okay, so we want to know at a fundamental level how does it work, and then we could always lean on the documentation for the actual config help. Okay, so we're starting at profile 0 here, and actually let's read some of this basic information first because there's some things here that correspond to all of the profiles. which is, okay, it says an mVPN profile is configured for the global context or per VRF. That's just going to be the VRF syntax. That's fine. Okay, for the profiles, multicast routing must be enabled for the VRF. IP multicast routing for VRF1. So in our case, we do multicast routing twice. Once in the global context and then once under the VRF. Okay, fast reroute we don't need to worry about right now. What I'm looking for is a section that says MVP or MDT, which is this. Okay, so for profile 1, or excuse me, for, profile 0, it says for this profile, PIM must be enabled on the global loopback interface, which in general, you do want to enable PIM on every single interface, including the loopback. So if you need to, let's say you're building your MPLS layer 3 VPN, you now configure PIM on one interface, or excuse me, if you don't configure PIM on the loopback, then the profile is not going to be functional. So when you're enabling PIM, even on the customer side, just enable PIM on the loopback interface. It's not going to hurt anything to have PIM on too many interfaces. Okay, next portion is the address family IPv4 multicast distribution tree must be used for all types of PIM signaling in the core. So this means that under BGP, we're going to have this new address family identifier enabled.